Ion quiz number 5 contains perchlorate through hypoiodite, and we're going to learn some of the most important rules that you're going to need to know about ions ever since we learned the charge columns. You'll notice that all of these are negative ions, and up until now, negative ions always ended in IDE. But now we're going to see that negative ions can also have two other endings, and these are the only three endings that can ever have, and those endings are IDE, ATE, and ITE. Every negative ion always ends in one of those three things, so if you ever get a negative ion on an ion quiz, you had better put one of those three endings. So how do we determine which of these three it is? Well, you'll notice that each of these has ITE or ATE as their ending, and none of the IDEs. And the other thing you'll notice is that every one of these contains some element, iodine or chlorine, with oxygen in it. And so the ones with oxygen in them always have these ATE or ITE endings. Well, I shouldn't say always, but what I should say is that if you have an element accompanied by oxygen, then most of the time it's going to have an ATE or ITE ending. The other thing you'll notice is that we have these stems. We have this chlor, 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 chlor. That's the stem of the ion. And you have different endings and different prefixes. And so today we're going to see how those endings, the prefixes, and the suffixes come together to tell you a lot about the ion. You'll notice down here we have iode, 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 and those all begin with iodine, just like the chlors begin with chlorine, Cl. This is a Cl, by the way, not a Ci. It's a lowercase l, not a capital I. Please don't make that mistake. If you look at these two, you'll see how I's look different from capital L so that you won't confuse them. So what are we going to do here? Well, the first thing that we want to do is we want to learn the ions that end in ATE. Always begin by learning the ions that end in ATE. So in this particular list of 7 ions, we really only have to sit and memorize 2 of them. We have to learn the chlorate and the iodate. None of these others have to be learned. What we want to do is we want to learn that chlorate is ClO3 with a -1 charge, and the iodate is IO3 with a -1 charge. There's really no trick to that. You just have to memorize that. So if you can do that, if you can memorize that, we can then derive all of the other names by a few simple rules. But using these rules relies on the fact that you have learned the ones that end in ATE. So, you might ask, well, why didn't I highlight this one that ends in ATE? And we'll see for that in a second. You'll notice that has a prefix, per. We don't even need to memorize the ATE endings if they have that prefix on them. Prefixes are some things we don't have to memorize. We can use a rule. So what is that rule? Well, let's look here. If you have a prefix in front of the ATE ion, for example, if you have a prefix of per, what we're going to do is add an O. So if we look up here, we have chlorate, and then we have perchlorate. The only difference is that per prefix. And you'll also notice that the 3 here becomes a 4. So that per turns a ClO3 into a ClO4. So the rule is if there is a prefix, add an O. And you'll see that that also works down here. Here's our iodate. Add the prefix per to it and add an O, and you get per iodate. Excuse me. Second rule is actually the opposite. Rather than looking at adding an O when you add a prefix, if the ending changes from an ATE ending to an ITE ending, like we did here, chlorate becomes chlorite, iodate becomes, oh wait, there isn't an iodite on here, but you could figure out what it is. If the ending changes to ITE, we're going to remove an O. So here's ClO3, ClO2, difference of 1 O, 8 becomes ite. So learn the eights, add an O, and you get a per. remove an O, and you get the ending changes from ate to ite. Also, you'll notice that the charge doesn't change when you make any of these changes. When you go from chlorate to perchlorate to chlorite to hypochlorite, they all have the same charge. So once you learn one of them in these families, you don't have to learn new charges. The next thing that can happen is that we can have a prefix hypo. See down here we have this hypo, here we have this hypo. So if you have the prefix hypo and the suffix ite, which by the way always go together, you will always get hypo and ite. There's no such thing as hypoate. You wouldn't have hypoiodite, you wouldn't have hypochlorate, you wouldn't have hypochlorate, you wouldn't have hypoiodate. Not sure what I said that first time, but it should, you could get hypoiodite, obviously. So whenever we get that hypo prefix, as we do here and as we do here, what we're going to do is remove two O's. So chlorate becomes hypochlorite, and the number of O's drops from 3 to 1. Now we don't put a subscript of 1, that's assumed. So similarly, we go back here. Here's our iodate. And this is all based off of the ate formula. That's why we learn the eights. So we go hypoiodite. We lose an O from the ite, and we lose an O from the hypo. So we should go from IO3 to IO, and the charge remains -1. Another tip to remember, if it starts with hypo, then it always ends in ITE. And it's always basically going to be the same formula. It's going to be some element, and then an O, and then a -1. For my ions, that's always the case. Here's hypoiodite, IO -1. Hypochlorite, Cl, O -1. Hypobromite that you'll see next week is Br, O -1. And so those are the rules for prefixes and suffixes associated with the number of O's in an oxyanion. So to review, we have learned the eights, ATE. If you add an oxygen to that formula, the name will get the prefix per. If you remove an O, the name will go from ate to ite. And if you remove an additional O, the ite will gain the hypo prefix, and none of these affect any of the charges. Really important rules. There are going to be ions for the next several weeks that follow this trend, and it's going to save you a lot of time to understand how that works.